Torricelli's theorem. Torricelli's theorem states that the speed v of a liquid following under the force of gravity out of an opening in a tank is proportional jointly to the square root of the vertical distance h between the liquid surface and the center of the opening and the square root of, twice the acceleration caused by the gravity, 2g, or simply v equals to the square root 2 times h times g. And now for the experiment, we say that you have a cylinder with an open top like this, and you put some proper fluid, let's say water in it, and at the bottom you pull a little hole like this. And the question is, how fast will that be going? So to start at the top, we are gonna say that it's position 1, and that equals to atmosphere pressure. And let's say that this is position 2, that is equal to atmosphere pressure 2, because outside is the same pressure, and we have a certain height that is called h, and here is g1 and here is 0. So using Bernoulli's equation at the position p1, we got p1 plus 1/2 of the density of the water, times velocity 1 squared, plus density times gravity times g1. This formula can be simpler because v1 is equal to 0. So simplifies 0 because here velocity is equal to 0, because we have only potential energy, and that equals to P1 plus density times gravity times G1. But what about P2? P2 equals to each other because energy is conserved, so at location P2 we got P2 plus 1/2 density times velocity squared plus density times gravity times g2. But the location g2 is equal to 0. So we can simplify, and we have P2 plus 1/2 density times velocity 2. Then we can equal these two equations, and we have that P1 plus density times gravity times g1 equals to P2 plus 1/2 density times velocity 2. But P1 and P2 are the same because it's atmospheric pressure, so we can eliminate also the density gone. So that eliminate, and the density. And we only got that, and that equals to the Torricelli's theorem, that is h, because h equal to g1, that is the height, and that's all. Experiment. Well, for the experiment, we have that can that has a certain height, has a hole right here, and another little hole at the bottom. So the experiment starts. I need to fill this with water. And put like this. And you see how the spirit is faster when the height is higher, and when becomes go out the water, the velocity decrease. Looks like I'm P. Wait. Well, this experiment we can see that the velocity of the water leaving the can is proportional to the height.